The last section of this chapter is arithmetic sequences, which should be pretty simple. The definition of an arithmetic sequence is the difference between each term in a sequence is the exact same. So if between two numbers and the numbers after that are exactly the same, then it's called an arithmetic sequence. Another word that you need to know is common difference. Common difference is the difference between each term within a sequence, which is also represented by the letter D. So I'm going to look at a couple sequences, determine whether or not they're arithmetic, and then later figure out how to find the nth term in a sequence. The first one is, if you're looking at the notes, is we're going to determine whether or not these are arithmetic sequence. Negative 15, negative 13, negative 11, negative 9, and so on. So the first thing we need to do is figure out the difference between each number. So in between negative 15 and 3, we have 2. In between negative 13 and 11, we have 2. In between 9 and 11, we also have 2. So because they're all the same, then we know that, yes, it is an arithmetic sequence, because they're actually all the same. And if we go back to the vocabulary, the common difference is the number that it's in between, or the number that's the difference between each term. So in this case, D is actually positive 2, because I could say negative 15 plus 2 is negative 13, plus 2 is negative 11, plus 2 is negative 9, and so on. The next one are a few fractions. 7/8, 5/8, 1/8, and negative 5/8. Determine the difference between each of the numbers, or each of the terms. Between 7/8 and 5/8, I have 1/4, or negative 1/4. Between 5/8 and 1/8, I have negative 1/2. So because already off the bat I know they're not the same, then I know this is not an arithmetic sequence, because they're not the same in between each one. Fairly simple. The next set of examples, well, the next example says to actually write down the next 3 terms in the sequence. So the sequence is negative 8, negative 11, negative 14, negative 17, and so on. So you have to come up with the next 3. And again, you should be familiar with how to do these. So we're going to find the difference between all 4 of these, between negative 8 and negative 11. It looks like we are subtracting 3. Between negative 11 and negative 14, I'm subtracting 3 again. 14 and then 17, I'm subtracting 3. So that means I want to subtract 3 to find the next 3 items in the sequence. So negative 17 minus 3 is negative 20. Minus 3 is negative 23. And then minus 3 is negative 26. So those would be the answers to that one. Okay, the next set of examples goes into where we're going to use a formula. This is when we want to find the 9th term of an arithmetic sequence. 7, 11, 15, 19. Now we could sit there and add whatever the difference is to this over and over and over again until we find the 9th term. However, if it also said to find the 100th term, I don't want to do that. Nor I don't think you do either. So there's a formula you can use to find the missing sequence. I'm going to write that we need to find the 9th. And we don't know what that is. So I'm going to move this off to the side. And actually what I'm going to do is No, let me leave it there. Sorry. I'm going to write down the formula. A sub n equals a sub 1 plus n minus 1 times d. All right, which each one represents. A sub n is the term. So what the number actually is. A sub 1 is my first term. N is my term number, meaning first, second, third, so on, 900. And D is our common difference. Okay, so now that we have our formula, we're going to take this information from our example and plug it into the formula to find out our ninth term. Our A sub n, that's what we're trying to find out. We're trying to find out what the ninth term is. Our first term is 7. The term number is 9. And then our common difference between 7 and 11, 11 and 15, 15 and 9 looks like 4. So it's positive 4. So then we just plug these numbers into our formula over here. Let me just finish the calculations. So we just figured out that our ninth term in this sequence is going to be 39. If we wanted to graph these terms, and I'm kind of skimming over some of the notes, but if we wanted to graph these terms on a graph, then you can make a table, or you can actually just use what you have. For example, our x and our y. X is the term number 1, 2, 3, 4. We'll go ahead and go to 5. Our y is what the actual term is. So in this sequence, our first term is 7. Second term is 11. Third is 15. Fourth is 19. And then 19 plus 4 is 23. So our fifth term is 23. And then we would graph these as ordered pairs. And it should come out actually fairly linear, because each term is being increased by the same amount. So this is how you would graph, and this is how you would find the nth term.